Okay, in this lesson, we're going to talk about maximizing revenue, trying to find the greatest possible revenue. Now, what is revenue? Revenue is generally the money generated from selling something. So for our definition of revenue, and you can get in much more technical, this entire topic, we're going to keep it very simple. Normally, I'd go do a lot more stuff, but given the current situation, we're going to keep it pretty simple and just cover the basics that you need to know. But generally, revenue can be calculated by the price of something times the amount sold. Now, this is just for basic revenue, right? All right, so let's look at our scenario. Right now, we're just looking at a school dance made-up scenario. Tickets to the dance cost $4. Okay, that's the price, and we think 300 people are going to attend. So let's talk about what the current revenue is, all right? All right, current revenue. All right, so right now, my price is $4. Times 300 people, right? Now, we shouldn't have more than one equal sign on the line, but I'm just going to say right now, if we multiply that, that should be about $1,200. It should be $1,200 what we generate, right? Now, we want to find the maximum revenue, and this is big in business. And again, we're looking at a simple version of this, but the idea is what should we set that price at to get the most amount of people, right? So due to, from some research, they're finding every time they increase the ticket price by 10 cents, about 5 less people will come. So we need to set up a formula for this. And this is going to be the formula you can generally use for any of these kind of basic revenue questions. I'm going to call it the changed revenue, or looking for the maximum revenue, okay? But we'll just call it the changed revenue for now. I can't think of a better name. Somebody else probably could, but I'm going to call it the changed revenue. Revenue. All right. Now here's what it's going to look like. I'm going to write it out, and then I'm going to kind of describe it. So we're going to start with our price again. What's our starting price? Okay. Start with our starting price here. Oops, hang on. All right, give myself a little more room here. And what we're going to do is add to it the change. What is it changing by? Times, and now I'm going to use the variable x here. Now you could use whatever you want, and let's describe what x is in a second. Let me just kind of write this out. Okay, here's our amount sold again. Okay, I guess I should have wrote sold up here, amount sold. All right, amount of tickets sold or whatever, plus or minus the change again. What are we changing by? Okay, times x. So what is x? Let's define what x is going to be here. So x isn't the price, it isn't the amount sold. X represents basically how many times we're going to change this. So x represents, I'm going to write this out here. X represents the number, just use number symbol, keep things moving, number of times we change the price, right? We change the price and the amount sold. So how many times do we want to do that, right? That's the question. That's what x will represent. So in other words, what I mean by that, how many times are we going to increase the price by 10 cents? And therefore, how many times will we lose 5 people, right? Because if we increase it by 10 cents twice, that's increasing it by 20 cents, right? But that means instead of losing 5 people, we'd lose 10, right? Or if we increase it by 30 cents, we'd lose 15 people, and so on and so forth. So x just represents how many times, and that's what we want to figure out. Let's figure out what is that x value that will give us the maximum possible profit. So let's write an equation for our scenario here. So I'm just going to use R for revenue from now on. So let's use an R here for revenue. What's our starting price? Well, our starting price is $4, right? And it says every time you increase by 10 cents. So let's use plus 10 cents, right? I'll just use 0.1 for 10. I'll put the extra zero, just right, 10 cents times x. So x will be how many times you increase it by 10 cents times the amount sold. Well, right now they're selling 300. And it says every time you increase it by 10 cents, you're going to decrease by 5 people. So let's minus 5 times x. And again, x. Okay, so there's our equation. So we want to find the maximum revenue. So generally, I'm going to move this up a bit so we can see here. We're going to end up, just keep moving it up a bit. There's our equation. Okay, we're going to have a parabola, right? It's going to look like this because we're looking for the maximum up here, right? So what is the value of x that will give us the maximum R, maximum revenue? So the first thing to do is, well, we want to find the vertex. This isn't in vertex form, it's in factored form, which will give us the 2 roots, our x-intercept. So why don't we do that? So step 1, let's find the roots, determine our roots, right? Well, how do we do that? Well, anytime you want to find your roots, those are your x-intercepts. So you set your y value to 0, right? So on our graph here, when y is 0, right? In this case, y is being represented by r. So when r is 0. So let's set r equal to 0 and find our roots. Now, this is the place where people make a critical error. Some people start simplifying this thing and then they go use their quadratic formula. And I shouldn't say it's an error, but man, you are doing it the longest way possible. It's already in factored form. So set r equal to 0 and let's just set both of these equal to 0, right? It's already factored, so we can just find our roots by setting these equal to 0. Now, I'm not saying you're wrong if you want to simplify this and use the quadratic formula, but man, you are doing a long version of something very easy. So let's divide both sides here by 10 cents. $4 divided by 10 cents, we're going to get negative 40. All right, so there's one of my roots at negative 40. So I think that'll probably be this guy. We'll write him as negative 40 over there. All right, sorry, kind of sloppy. My 4's all get squished. All right, now 300 minus 5x equals 0. Okay, so negative 5x equals negative 300. Divide both sides by negative 5. And we get x equals 60. All right, so there's our two roots. So what does that mean? It means if we change the price negative 40 times or 60 times, so like up here, right? If we put negative 40 or 60 in, our revenue would be nothing. So if someone said, what would you do to get no money? That's what we could do, right? But we don't want no revenue. We want to find the maximum revenue, right? Okay, so what's the second thing? Well, I want to figure out what the x value of my vertex is. Well, I could find that if I knew the axis of symmetry. So the axis of symmetry, the AOS, is that vertical line going through the middle. It's halfway between those two roots. So step 2. We're just doing the same skills we've learned in previous lessons, right? We're just applying it to a revenue problem. Let's find your axis of symmetry. All right, well, I can do that pretty easy. All I got to do is add the two roots together and divide by 2. So negative 40 plus 60 is 20, divided by 2 is 10. There you go. So my middle is at 10, right? And if we made an equation for this, this would be x equals 10. All right, cool. Well, how are we going to find the maximum revenue? All we have to do is sub it into the equation. So step 3, here we go, right? Sub in the axis of symmetry. All right, so let's sub that into our equation. So here we go. R equals 4 plus 10 cents times 10, because that's what we're going to replace x with, and 300 tickets minus 5 people, also 10 times. So what's going on here? This is how many times we're going to change it, right? So this means we're going to increase, we're starting at $4, we're going to increase it by 10 cents 10 times. We're starting with 300 people, we're going to lose 5 people 10 times, right? So if we simplify this a bit, 4 plus 10 cents times 10, that's $1. We're going to increase the price by $1. 300 people, 5 times 10, we're going to lose 50 people. So right now, if you look back up, I didn't read through all the questions it wants us to find, but all the things that want us to find all get determined right now at the end. A, what's the greatest possible revenue? Well, we're going to find that. What's the ticket price going to be? How many tickets are going to be sold? That's exactly what we're finding right this second, okay? So right now, our new ticket price, right, it was $4. Well, we're going to add $1. So our new ticket price is $5. We had 300 tickets minus 50. That means we're only going to have 250 people, okay? So the 1 is the increase in price. The minus 50 is how many people we're going to lose. Our new price is 5. Our number of people is 250. And if we multiply them, we can get the maximum revenue, which is going to be $1,250. So I can answer all 3 of those questions, right? Question A, what's the maximum revenue going to be? $1,250. Question B, what should the ticket price be? $5 per ticket. That's right there. Question C, how many tickets are going to be sold? That's right there. We're going to have 250 tickets. There you go. $5. I'm really sure per ticket. There we go. So all 3 answers you basically get right at the end of the question right there. So there you go. There's how you set up a standard revenue question. Now we can go a lot farther and do a lot more, but for now we're just going to stick to a standard one. Make sure you can get through that. Okay? Thank you, and check out the next lesson.